Welcome everyone to this lecture on environment setup. Before we begin showing you how to set up the course environment, I want to quickly explain the advantages of what a virtual environment is and why we use it. Essentially, Python libraries can change often and unexpectedly, and minor changes can cause code to break, which can impede the learning process. So for a real example of this, while I was filming the course, the Seaborn Data Visualization Library changed a call from distplot to displot, essentially removing that single T. And suddenly, all those function calls to displot suddenly had warnings on them that they were going to be deprecated into the future. And what we really want to focus on is learning about data science and machine learning, not these very subtle or minor library changes, when really all the concepts behind machine learning and data science and the algorithms are going to be set in stone by now, and we can use them regardless of what function call changes happen into the future. Again, we're very fortunate here that we're learning things based off mathematics and algorithms and fundamental intuition, rather than something like a web development framework that could have a very major change in the future. For our particular case of everything we're learning about, the changes that are upcoming in the future for all the libraries we're learning about are going to be very subtle and very small. But what we don't want to do is have to completely rewrite our code every time a library sends out a new update. So how do we fix this? Well, what we can do is create a virtual environment to hold the specific versions of Python libraries for our particular use case. And so what we've done is we've created a Python virtual environment file for you. That way you can follow along with the videos in this course, and you're going to use the exact same library versions that we use. And what's really nice about this is you can activate or deactivate this environment as needed, or edit libraries in the environment in case you ever want to upgrade yourself. So this allows us to balance between functioning code and keeping up to date with the latest library changes. We can also have multiple virtual environments for different projects. So you can have a virtual environment to follow along with the course videos, and maybe your own virtual environment where you keep everything up to date and make subtle changes as they come in to the latest updates of those Python libraries. So let's actually start by downloading the environment file. There's two ways of doing this. If you check out the right-hand side, you should see a download direct from Udemy, where you can actually check the supplemental resource for this lecture, and you'll notice the file is called requirements.txt file. I've also provided a backup Google Drive link to the same requirements.txt file. Either is okay as long as you're downloading the same file, just call it requirements.txt. So go ahead and download that file and save it to the downloads folder or desktop folder, essentially just somewhere where you know where it is. And now we're going to show you within Anaconda Navigator, we can create an environment, install from the requirements.txt file all the specific library versions, and then activate an environment or deactivate an environment. We'll also explore that requirements.txt file a little bit so you can see the inner workings of what's going on. Okay. Go ahead and download the file and then open up Anaconda Navigator. I'm going to go to Anaconda Navigator now. Okay, here I am at Anaconda Navigator. What we're going to do is on the left-hand side, go to Environments, and then you'll notice I already have a bunch of environments set up for the variety of courses that I teach. What I'm going to do is create a new environment by importing it. What we can do here is you can either create a brand new environment and then manually add in the libraries, or import from the requirements.txt file that you just downloaded. Click Import, and it will bring up this window here, and you can decide on a new environment name. You can call this whatever you want. For example, you can call it New Environment, and then what we're going to do is click on this little folder here, and then the first thing you have to do is over on the right-hand side, make sure you change the file type you're looking for from a conda environment file to a pip requirements files.txt file. That way, it will correspond to the text file that you just downloaded. In my particular case, I saved this file under desktop, and I have right here requirements.txt. So what I'm going to do is simply open up that file. But before we open it, let me actually show you what is inside that requirements.txt file. If I open up that requirements.txt file with Notepad, you'll notice it looks something like this. It's actually a very simple file. All it's doing is it's just telling Python the library to install and then the specific version. So you could easily come back and edit this requirements.txt file in case any libraries are updated by the time you're watching this, Or if maybe you want to downgrade and use a specific library version because it matches what's working at your company, for instance. So you can always edit this file as you see fit or add in more libraries. So I just want to show you that it's actually really easy and simple to set up. You just type in the library name, 2 equal signs, and then the exact version you want to install. And then you can just list them. And when you create the environment from this file, it will go ahead and install all of these. So these are all the versions of the libraries we use throughout the course. So I'm going to exit this for Notepad and then open this up with the import environment. And recall that we have to actually say pip requirements files on the bottom right. Go ahead and open this and then hit import. And when you're importing this, it's actually doing two things. It is both creating this new environment and it's going to install all those libraries. Keep in mind, this can take a while, especially if you have a slower internet connection. What I'm going to do is fast forward in time until this is done installing and creating this environment. Alright, now that it has finished installing, you'll notice that it lists a bunch of libraries available inside this new environment. Keep in mind that there's actually a lot more libraries shown here than what was in that environment file, and that's because many of these libraries that we had in the requirements.txt file have their own prerequisite libraries that are automatically installed. So just saying Jupyter in the requirements.txt file also installs Jupyter Client, Jupyter Console, Jupyter Core, etc. So that's why you see so many different libraries here that weren't specifically shown in that requirements.txt file. So once we have the new environment ready to go, we can come back home and then see the applications available on new environment. So if you click here, you'll see a much shorter list than all the environments I have, but every time you start up and follow along with the course, you want to make sure that you change from base root, which is the base environment, the default one that is, and then come back here and make sure you're setting up the new environment. So whenever you're following along with this course, make sure that you have applications on and then the new environment you created selected. And then what you can do is you can go ahead and click here on Install Jupyter Notebook. And then what that's going to do is it's going to install the Jupyter Notebook system directly in this environment that we set up. And this is just to make sure that you understand that Anaconda Navigator has all these tools available to you that you can install on then any of these environments. And this directly connects the development environment with the environment you just created. And you can do the same thing if you prefer something like Spider or Jupyter Lab or Orange 3 for working. But what we've done is you'll go ahead and just click Install on Jupyter Notebook with your application in that new environment. And then what we're going to do is after this is installed, let's open it. So you can see here, once it's installed, it moves over to the left. It's ready to launch. Hit launch, and this will open in your browser. This is now opened in our browser. Let's make sure that our environment is working by saying select new, Python 3 notebook, open up that new notebook, and you should be able to say something like import pandas, do shift enter, and if that worked, that means you're working with pandas and it's in this environment. And then you can say pandas dot underscore version underscore underscore. In fact, this is actually 2 underscores here, so keep that in mind. And if you run that, it should report back exactly 1.1.2. Again, this is the version that was installed in that requirements.txt file. So again, if I bring over that requirements.txt file, you'll see now this pandas version matches exactly with what is shown here. Okay, so we are ready to go. We have our environment set up, and we specifically have connected our development environment for Jupyter to the existing environment. All right, that's all we need to know for now. I'll see you at the next lecture. Welcome back to the Python Crash Course. Let's get started with part 1. I'm going to hop over to a new Jupyter Notebook to get started. Let's start off our crash course with the very basics, starting with numbers. So Python has 2 main number types that we're going to be working with. It has integers, which are just whole numbers, or what is known as floating point numbers, or floats, which is essentially just with decimals. And if you ever want to check the type of any object in Python, you just use the type function. So I can say type1, I can see there it's an int for integer, or type of 1.0, and since it has that decimal information, it's a floating point number, or a float. Let's go through some very basic math with Python. So all of this you would probably expect to work. 1 plus 1, so that's addition. Multiplication is just an asterisk, 1 times 3. Division is just a slash, so 1 divided by 2. If you want to do exponents, for example, 2 to the power of 4, it's just 2 sets of asterisks. We can see that's 16. The modulus operator, or mod operator, is just a percent sign, as it is in various languages. So 4 mod 2 brings back 0. And remember the mod operator, in case you're unfamiliar with it, it just returns the remainder after a division. So 4 divided by 2, since 2 goes evenly into 4, it just returns 0. And for example, I can do 5 mod 2. That brings back 1 because 5 divided by 2 has a remainder of 1. And then quickly, order of operations is followed in Python. So for example, if I have 2 plus 3 times 5 plus 5, here it brings back 22, but if I actually want the addition to happen before that multiplication, I can specify a specific order of operations with parentheses. So here I'm going to say, hey, do the addition and then multiply them together. So now when I run the cell, I get back 50. The basics of variable assignment are also quite simple with Python. Python prefers snake casing, meaning if you have multiple words inside a variable name, you separate them out by underscores. So this is just by convention. There's no really strict rules on this, but we'll talk about this later on as well. But for instance, I can say equal sign. There's a name of a variable. So I can do this multiple times. So x is equal to 1, y is equal to 2, run that, and then I can say something like x plus y, and there I get the variables. Okay, so we talked about numbers and variable assignment. Let's quickly talk about strings. So strings can be a single quote or a double quote. So there we see strings with both single and double quotes. And for instance, if you wanted to say something like, I don't like that, you could just wrap it all in double quotes. So I don't like that. And notice now, even though I have a single quote here, because I'm wrapping the whole thing in double quotes, I don't get any sort of error. If I had done this with single quotes, then Python is getting confused because it doesn't know where your actual string ends and starts. So it says, oh, is this the string or is this whole thing the string? So you can just mix up these quotes, double versus single, to actually make everything work correctly. Now notice here, I'm actually getting in an output cell the string. If I want to actually display the string, I can print it, which means I can do something like print hello. And notice the difference here between just saying print hello or hello. If you're dealing with another IDE, you're going to be having to print your variables to see them during the output. For Jupyter Notebook, however, a lot of times it displays the very last line in a cell. So you can see here, it's just displaying that string. Versus here in this top cell in 20, it's actually printing out the string. So notice the difference here. There's no quotes, there's no out cell, versus here when I'm just asking for the string back, it returns the out cell plus the string itself. So that's printing, the very basics of it. Let's show you how to format print, which is essentially also known as string interpolation, which is a way to insert things into a string. For example, if I wanted to say something like my name is, and then leave some sort of space there for me to input names, I could do curly brackets and then off of the string call the .format method, and then I just pass in whatever I want to be there. So for example, I'll put in Jose. So we'll print this whole thing out. So put this entire thing under print, and now I can see it says my name is Jose. So this is known as .format on a string, or string interpolation for a general sense, but it's a way to insert objects into a string. And the curly brackets there indicate what's going to be put in. Now I can do this with multiple objects, and the way I can do that is by actually naming them or ordering them. So we'll say my name is blank, and we'll say my number is, and then we'll also have curly brackets there, and then I'll pass in a second argument inside a format, and I'll put in something like 10, but let's put it in as a string so we don't get any errors here. Okay, so I say my name is Jose, and then it says my number is 10. So I'm passing in that string 10 and then putting it in here. Now if I don't pass it in as a string and try to run this, it also works, but you should be careful with that. Sometimes you may get errors if you try to add stuff together inside the string. So I'm just playing it safe, passing that in as a string. So that's a really common thing to do. Another thing to do with format is to actually label these variables, which you'll also see. Let me show you a quick example of that. So we'll say first, and we'll pass in x, and then say second, and we'll pass in y. So look what happens when I actually say for these things, xxx, YYY. This is just to make it kind of really obvious what's happening here. Whoops, I get a key error because I actually labeled a key. So it expects a variable x to be inside format, and it will also expect some variable y to be inside .format. So let's add those in. We'll say x is equal to this triple x, and y is equal to this triple y. So running this again, now it works. So I see first, triple x, second, triple y. So you might be wondering, well, what's the point of this? Well, now I don't need to worry about the order things are in format. Or I could use objects more than just once. For example, I could just say YY. Now when I run the cell, it says first YYY, second triple Y. Or I could reverse the order. Say Y is first and then second is X. Running this, I can see now I have a lot more control by actually naming these variables inside of .format. So that's the basic use case there. Let's move on to talk about lists. So lists are also known as arrays in other languages, and the way they work in Python is actually quite simple. All you have to do is use square brackets, and you separate the different items inside of the list by commas. So here I have a list of numbers, 1, 2, 3, but I could also have a list of strings such as A, comma B, comma C. So that's another list. And I can even mix data types. So I can say there's a number and there's a letter, run that, and Python doesn't complain. Now if I actually want to grab objects from a list, I can use indexing. So let's show you how to do that. I'll create an object called myList and set it equal to a list of letters. So we'll say A, B, C. Now as a really quick note, what you should never do is if you're typing a variable name and you notice that it's suddenly highlighted for you, then you're probably going to run into issues there because this basically indicates that this is some sort of reserved keyword. So if you notice that it's being highlighted, then you're having an issue. Now, if you've defined your own function and you expect that sort of behavior, then that's totally fine. But notice here it's being highlighted, so we're going to try to avoid using list as a variable name, which is a good call. And let me zoom in just a little more here so we can clearly see what's happening. So I have my list, it's equal to these A, B, and C. Let's say I want to grab the very first item in my list, A. Well, I can just use an index call. So we grab the name of the list, add in square brackets, and then indexing starts at 0. So if I want to grab the very first item, that letter A, I pass in a 0 there, and it returns the letter A. If I want to grab the very last letter, C, I have two options. I could count over and say 0, 1, 2, and pass in the number 2, and I get back the letter C. Or let's say this was a super long list, and I just wanted to grab the last letter, but didn't actually want to count all the way through. Python supports negative indexing, meaning I can say, okay, starting from 0, go backwards 1, which is essentially saying loop all the way around and grab -1. And there we have C. Okay, so that's the basics of indexing with a list. If I ever want to change an item in the list, I can index it and then set it equal to some new item. So we'll say my list of 0 is equal to new. And if I run this, I don't actually see any output. So let's check if my list was actually changed by just asking for my list in a new cell. And there it is. I have new B, C. So that's the way you can define a new or reassign an object in a list. Now, if I don't want to reassign an object in a list, but instead add on to that list, then all I have to do is use the append method, which appends a new item to a list. So let's show that. Going to clear that cell. Right now I have my list, which is new B and C, but I want to add a fourth item, so I'll say append, and then let's add the letter D to the end of the list. So I run that, I don't get anything back since the action is not actually returning anything, but it is affecting the list. So if I ask for my list back, I can say new, B, C, and D. I can also nest lists. So let me show you what I mean by that. I can have my list is equal to, and I'm basically creating a new list here, 1, 2, and then the third item can actually be a new list. For example, 100, 200. So if I look at my list now, I see I have a list inside of a list. And you can do this as many times as you want. However, be reasonable. You don't want to do a nest inside of a nest inside of a nest, etc. But if you ever want to grab an item from this list, for example, let's say we want to grab 200 just by itself, well, I know that this list completely is the third item. So that's 0, 1, 2. So I pass in 2, and I get back that list, 100, 200, and I can actually stack index calls. Meaning if I want to grab 200, well, that's index 0, index 1. So I just say this, 1, shift enter, and then I grab 200. So that's a nested list, and that's the way I can actually grab stuff from a nested list. I can just stack these index calls. So that's going to be useful if you're working with a matrix or something that has 2 dimensions. Usually that's represented as a nested list. So we'll see a little bit of this throughout the course, but it won't be anything too crazy. So that's the basics for all you really need to know about lists or arrays. Again, they're just a sequence of items or elements that are in order, meaning you can index them with a number. Now, let's talk about dictionaries, also known as hash tables in other languages. So dictionaries use this sort of notation. I'll say D is equal to curly braces, and then they have a key, which is always a string there, and then some sort of item. So this is known as a key value pair. So I'll have key, and then let's make a value 1. Then we have a comma there, and then we have key 2, colon, and then some second value. So I run that, and then if I want to access items from this dictionary, I pass in the key name. So what I want to do is access values based off of their key. So I'll grab a key here, key 1, and that returns value 1, which makes sense. And if I ask for key 2, then I get back value 2. So something to keep in mind that is sometimes confusing for beginners is that these hash tables or dictionaries in Python, they do not retain any order. So unlike a list, these guys don't retain any order. So whatever order happens to be printed out, so let's say I wanted to print out this dictionary, it may not actually be in the order that you would expect. So here, notice I get key 2, value 2, key 1, value 1, even if I defined it 1 and then 2. So again, dictionaries don't retain any order. And that really has to do with the way a hash table works, which you don't actually need to understand for this course. The basic idea is these are just key value pairs. So instead of items being in a sequence, they're matched up with key values as a pair. So you can easily access items based off their key. And this is a really great way to store things where you need really quick access. All right, let's move on to discuss booleans. So booleans are quite simple in Python. It's just either true with a capital T or false with a capital F. Not much more to it than that. Now, as a quick note, a lot of programming languages, Python included, have what's known as truthy, which means if something is truthy or falsy, which essentially assigns some sort of truth or false behavior to a lot of objects. So for example, if you're ever working with if statements, which we'll discuss later on, and you don't really want to use a Boolean, you can also use numbers. So zeros are treated as a false statement. So if you say if 0, it happens to be false, and ones are treated as a true statement. So if 1, then it actually does something. We won't see too much of that in the course, but if we do see it, I'll make sure to let you know. It's usually pretty obvious when you see it in actual coding. But that's something I want you to be aware of. Now there's 2 more data structures I want to discuss. That's tuples and sets. Tuples are very much like a list. They're a sequence of items, but notice here that they're defined by using parentheses instead of these square brackets that we saw earlier. Now you might be wondering, well, why use a tuple versus a list? Well, tuples are immutable, meaning you can't reassign the items inside of them. So I have t of 0, and if I try to set this to new like I did for a list, I will get a type error, and it says tuple object does not support item assignment. So you want to use tuples when you want to make sure a user can't actually change anything inside of this sequence. So that's the use case of a tuple. And then finally, the last major data structure of Python is the set. Looks a lot like a dictionary, except there's no key value pairs. It's just this sequence of items. So a set is an unordered collection of unique elements. So what does that mean? It means since all the elements have to be unique, if you add in multiple instances of an element inside of this set, it's going to reduce this to just the unique elements, which is 1, 2, and 3. Alright, that's really all we need to know as far as the basic data structures, and we'll constantly be reviewing this sort of stuff as we continue on throughout the rest of the course. And a lot of the syntax we'll be using is mainly with Spark data frames, so this is all you really need to know. Coming up next, we'll discuss comparison operators, logic operators, and then how Python deals with if, else if, and else statements, as well as certain loops like for loops and while loops. Thanks, and I'll see you at the next lecture.